Hi, I'm Nick Charpentier, a solutions engineer with Great Bay Software. Today, I'll be providing a brief demonstration on Great Bay Software's Beacon solution in regards to Beacon Endpoint Enforcement, the active response and port level security abilities. So, first off, if you remember from previous videos, we talked about how Great Bay Software's solution can provide port level enforcement and actionable eventing. So, first off, we're going to start speaking to the active response. So anytime an alert is triggered, such as we see here, if a rogue device comes on the network, or a MAC spoof is detected, or if a device starts exhibiting anomalous behavior, you've got a couple different enforcement methods. It can either be an event is triggered, sends off an alert where an admin is notified of that type of an event, and then you can also do something such as kick the device off the network, move it to a quarantine, or something like that. So first off, we're going to show you the active response. So I'm going to show an example of a netbook that is currently on the network and acting as it should, and everything's good to go. But we're going to show an example of like a third-party integration with something such as a AV solution or asset management database or something like that. Another example could be something like ServiceNow that would record the information about the endpoints and then also be able to tie in information from those other third-party solutions. So we're going to show a specific example where this netbook is flagged not compliant by some other type of a scan or some other type of solution, and then by leveraging Beacon's JSON RPC API, we can ingest that information, update the endpoint, transition the profile, and then actively kick it off the network. So first off, we're going to go ahead and search for that specific netbook. So I'm going to drop the MAC address right in the simple search bar and search for that. And we see the netbook here. So we're going to go ahead and click on this device, and we can see that it's classified as a Windows 10 machine. It's on Aristotle port 22. And we'll actually pull up the switch real quick just to validate that it is in fact on that switch port. So I'm going to bring that window right over here, and we'll log into the switch. And we'll show interface 22. So we see that the port is up, everything's good to go, the device is communicating on the network. We're going to go ahead and just do a quick overlap here so you can see that. So now we see that it's connected on Aristotle, port 22 as it shows in the Beacon UI. Everything's good to go there. So what I'm going to do is, now this would be all done in an automated fashion on the back end, as a solution such as your back-end antivirus management system detects that a device has a malicious file on it or that it's not compliant for some reason. It's going to be able to automatically send that message over to Beacon. Beacon will ingest it via the user data field, which would normally show down below here if there was something populated. So since there isn't currently, we have not received any information. What I'm going to do is go ahead and send that message over so it flags this device is not compliant, and we'll see that update immediately. So that message has just been sent over. If we scroll to the bottom here and go ahead and refresh this, now we'll see that it went from the Windows 10 profile at the top here at 74% to the GBS compliance check failed at 95%. We see the user data field has been populated. It shows the owner as me, and the compliance check had failed. So what that means is that's also going to trigger an event. So if we go ahead and go back to the home dashboard here, now we're going to see first off there is an event that's triggered, and then we see a profile change as well. And based on that occurring, it's going to go ahead and fire off an event that kicks that device off the network. So if we go ahead and look at the switch port again, we'll clear the screen, go ahead and show that interface. Now we see that that line is down. So based on receiving new information on that device, updating the profile, triggering an event, we are able to immediately mitigate that risk and kick that device off the network. Now that's kind of the more heavy-handed approach where we're just fully removing it from the network. Now we're going to show you and transition to the port level enforcement ability. So we're going to discuss if Beacon is deployed as a full-on NAC solution where we have full port level security enabled, and we've got it completely locked down where if a device is untrusted, never been seen on the network before, and you try to plug something in, it will not get on the network without being, pre-provisioned access or being sponsored. So we're going to go ahead and pull up the MAC address of a D-Link camera, and it's just one of those inexpensive IP-enabled cameras that you can buy at Best Buy, and that's just an example of a device that should not be allowed on the network. So I'm going to go ahead and show that we have never seen it before within the Beacon system here. So I'm going to search that MAC address, no results returned, so we've never seen this device before. And I know that it's currently connected to port 39 on Aristotle in the lab, and that port is currently turned off. Therefore, it's simulating plugging in a device on the network for the first time by enabling that port. So I'm going to bring up the terminal window again. We're going to show interface 39 instead. And now we see that that port is currently down. So the camera's plugged in, the port is down. We're going to go ahead and turn that port on so that we can simulate that device being plugged into the network for the first time. So we can actually do that from the Beacon user interface. So we're going to go down to Endpoints by Network Infrastructure Device, go to the Minnesota lab, click on the Aristotle switch, and then scroll down to port 39. So here we see port 39. It says it's currently down. Let's go ahead and turn that on. So now we're going to pull up the terminal window, clear out the screen, and then show that that port is now on. So now we see that that port has been enabled, and we're going to go ahead and just query that MAC address one more time to see that Beacon has now detected the device based on the radius accounting data. So we'll scroll to the top, search the MAC address again. Now we see that we've actually detected that device. So if we click on this MAC address, we're going to see the summary for this device is, here's the MAC address, and it's a D-Link International MAC vendor. We have no MAC to IP binding because the device has not obtained an IP address. It has not communicated on the network yet. If we look at the radius accounting information, we see that the status is stopped due to user error. In other words, it tried to authenticate, it failed, so we blocked access. We did validate now that it sees it as actively connected to port 39 on Aristotle, but if you were to walk back there and look at the switch right now, the port would just be orange. It hasn't turned green yet because it has not been permitted access to the network. If we view the profile data, we're going to see that out of all of the fields here, the only thing populated is the radius accounting information. So now we're going to discuss what that onboarding process looks like. So instead of this being a D-Link camera, let's just pretend this is actually a new employee that started at your company and they're plugging in their computer for the first time. It hasn't been connected to the network, it hasn't been pre-provisioned access. So they plug in, no network connectivity, no internet access. They call the help desk. The help desk validates the employee, validates the device, and then it's extremely quick and easy to jump in here and authorize that device. So first off, we're going to go over to the reporting tab and show the radius authentication report. So this is a report that any of the help desk users could jump into and view. And on this example, I've only got 4 ports or 4 devices connected on the authenticating ports in my demo environment. So we're only showing those here just to make it simple and clean and easy to understand. So we see that there's 3 not authenticated and 1 authenticated. And that's exactly what would be reflected on the switch if we go ahead and show the authentication sessions. So if I show that now, we see that sure enough, there's 4 devices connected. 1 of them was successful, the other 3 have failed. So the user will say, well, I'm trying to plug in a D-Link device and I'm not able to get on the network. After everything's been validated and we say that device should be allowed on the network, help desk agent can come in here and just sponsor that device. So we're going to go ahead and click sponsor, select the GBS sponsorship profile, and click add sponsorship. What will occur now is the device will go through the re-authentication sequence, and you're going to see a little bit of a transition in profiling. So it's going to go from first off a D-Link device to the GBS sponsorship at a 25%, so the certainty value will increase 10%, and that will grant it temporary access to the network. You can also define a timeout, so if you want to give them, just a few minutes, a few hours, or so on, that would be perfect for people such as a vendor or contractor that may come in to do a little bit of work. But you're going to see that graduation and profiling. Then the device will be authenticated, allowed to communicate on the network. The radius authentication status will turn green, and the device will, send out the DHCP request to get an IP address, and everything will start communicating as normal. Once we receive that new information and we see that DHCP request, you'll see another graduation of profiling. So we're going to go ahead and just walk through adding sponsorship, you're going to see that profile change, and then we're going to see this status update to green. So we're going to give it just a second here to refresh. Alright, so now we see that it's refreshed, and it's graduated from the D-Link devices to the GBS sponsorship, all the way up to the GBS D-Link corporate-owned profile. So we've already gone through the entire sequence of authenticating the device, allowing it to release, the DHCP request, obtaining an IP address, and now we've updated all that information. The status is green. If we go ahead and pull up the switch again, we'll clear out the screen, show the authentication sessions, and now we see that according to the switch it says authentication successful. Beacon interface reflects the same information, and if we view the profile data, we're going to see that now we've received all the DHCP information. So that shows just how easy it is to not only have a safe and secure access control solution that's easy to manage and onboard devices, but it also shows that it's going to reflect all that information within the user interface and from a reportability standpoint. Next, we're going to discuss the Vlan switching abilities. So the Beacon solution has the ability to dynamically update Vlan access based on what we've profiled the device as. So you can imagine the profile as being the policy. So because this D-Link camera lives in this profile, that means it's granted access to the generic data Vlan, which in this example is Vlan 30. So if I go ahead and show the Vlan information, we're going to see that pretty much everything is on the data Vlan, which is Vlan 30. So if we were to receive new information that caused the device to be reprofiled, and maybe it needs to, just like the example we showed before of the device being flagged as not compliant, and maybe instead of kicking it off the network, we'll move it to a quarantine, which could be an internet access only VLAN that's isolated from all of the other corporate LAN, and it's only going to go straight out to the internet, so at least the device is still functional, but you can ensure that you're mitigating any risk of if there's malware on it or something that might spread across the rest of the network. So we're going to go ahead and sponsor that device into the quarantine just to show what it looks like when the device automatically moves over to that VLAN without influencing the configuration. So just to validate real quick, we're going to show the running config so that we can show that the default switch port access is VLAN 30, which is validated right here. So interface 39 has access to VLAN 30 by default. So we're going to go ahead and dynamically update that access simply by changing the profile and show that we are not changing the config, we're just updating it via the radius authentication protocol dynamically for that session. So we're going to show the VLAN information one more time. We see that that device is on VLAN 30. We're going to go ahead and sponsor this device into the GBS quarantine. Hit add sponsorship, hit OK. And then we're going to give it just a second here. We see now again that this has transitioned the profile. It's at a 95%. So based on this profile residency, that is going to influence what access that device has to the network. So we're going to give it just another second here. Pull up the terminal window one more time and show the VLAN information. Now we see that this device has automatically and dynamically moved over to VLAN 999, which is the quarantine. And just to reiterate one more time, we'll show the current running config and validate that that device has been moved over to that VLAN for that session only. And we do not require any admin credentials to dynamically update the configuration on the fly. So this is all done through the radius authentication protocol, therefore ensuring that you have a secure network access control solution that is real-time, dynamically updating, and does not require any type of administrative access to your network infrastructure. So that completes this demonstration today. Thank you for watching, and have a great rest of the day.